Okay, so here we have a bit of a fun target, but then again, I think all math is fun, so my opinion is very subjective. But hopefully you're with me with this target of maintaining the balance of equations. And when I asked a bunch of students in class what maintain means, many of you know already, it means like keeping something the same. So keeping the balance of equations. Again, these notes, if you don't have them through absence or for whatever reason, must be in your notebooks. We are doing a notebook check before our algebra test, which is coming up in about a week and a half for some of us. Okay, so here's an equation, okay? 4 equals 4. Whenever you have that equal sign, you have an equation. And we would say this equation is balanced, and we have these balance scales to signify an equal relationship. 4 equals 4, everything's balanced because it's like the same thing. Imagine you had 4 apples on the left-hand side and 4 apples on the right. 4 equals 4. Now watch what happens. What if I were to add 1 to this left-hand side? Is this equation balanced? And the answer is no. If this was an interactive balance scale thing, it would droop down a little bit because it's a little bit heavier, because now you're looking at 5 equals 4, which is just not true. So to keep it balanced, we have to add 1 to the right-hand side, and now it's equal again. Okay? So we have a principle here in algebra that's going to carry us into the next lesson and beyond, that whatever you do to one side, we'll call it the left-hand side of the equal sign, you must do the exact same thing to the right-hand side. Now, for this one, I could do whatever I want all day long. What if I put parentheses around it, multiply it by 5? That's all fine and dandy, as long as I do the exact same thing to this side. And now I have 25 equals 25. And finally, for this slide, what if I just erased this expression and just put the number 25? Okay, is this still a balanced equation? And the answer would be yes, because you still have a value of 25 on each side. So it's very important balances of equations. Okay, here's another example of scales, and 6 equals 6. You can see the 6 blocks on the left-hand side. We need to start thinking about the middle of these balanced scales as like an equal sign. Okay, so 6 blocks is going to equal 6 blocks. This is a balanced scale as well, and we know it's balanced because of the height of the scales themselves are equal. Okay, so we assume equality because they fall along the same height. Okay, you don't see one that's higher than the other. So if we assume they're equal, which we can, we then have to start figuring out the different values for the different parts of the scale. You can see we have an X, looks like an envelope, and then 3 little circles, and on the right hand side we have 7 little circles. So I asked some really open-ended questions as far as what can you observe. I asked this in class and y'all had some really good answers, and many of us saw that the value of the X is 4, and you figured that out through some mental math where you have 7 circles over here, okay, and you have 3 circles over here. And assuming it's balanced, which it is because of the height of the scales, that would mean there has to be at least 4 if you want to think about it as in the envelope, or at the very least we would just say the value of that X is 4 because it would make 7 on each side. So that's the kind of stuff we want to be able to figure out. There is a method that actually makes it a little bit easier. So let me quick show us that, and we'll apply it again in the next example. Remember we said whatever I do to the left-hand side of the equation, I can do to the right. So I can cross one little circle out here. That's fine as long as I do the same exact thing to the right-hand side. And as soon as I do that, it's balanced again. Now let me do it again. I cross one little circle on the left-hand side. That gives me freedom to do it on the right-hand side. And one more time, get rid of this last red circle on the left-hand side. I'm able to do that because I still have at least one more circle over here. Now at this point, I can't cross out anything more because there's nothing that's the same that is on each side of the equation or the scales. So what I'm left with is X equals 4. Okay? Some of us did that through mental math, but some of these balance equations are going to get a little more difficult. So my suggestion to you, to make it easiest on yourself, is to cross out one thing at a time until you have, well, it's got to be the same thing on each side, right? I'm sorry, this one thing on the left-hand side, that same thing must be on the right-hand side like we just did. And what we're left with is x equals 4. Okay? If you want to think about what the original equation was, since this is an equation because there's equal sign, the original equation, is x plus 3 equals 7. And we still have the same solution because it's the same equation. X is going to equal 4. And somebody brought up a really good question during class. They kind of saw this as 3x because they said, Mr. Doc, didn't you say when there's a number right next to a variable that that's going to mean multiplication? And that was a really good question, a really good point, because that is true. But with these balance scales, you want to think of these items as like individual items. You know, since they're red and they're circles, if you want to think about them as apples, like the right-hand side, you have 7 apples. You have 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Here you have 3 apples, and we figured out the x was 4, but it'd be like 1 plus 1 plus 1, or 3. And that's why we really kind of treat these balance scales like addition. Okay, let's do one more example, and then you'll get to your indie work if you didn't do that already. And please also draw this example in your notebook. So, again, this is perfectly balanced because of the levels of the scales. And we're trying to figure out the relationship. Can't quite see it here because I zoomed in, but this is a textbook question that says, find the relationship between the shapes. Okay, that's kind of saying, the same thing as saying, try to find the value. So, again, the method that I think is the strongest, cross out things that are the same on each side. Some of you might be able to see on the right-hand side of the equal sign or the scales, you have 3 circles. Therefore, you can cross out 3 circles on the left-hand side. Or if you just want to cross them out one at a time just to ensure accuracy, that's fine. But I can see there's 3 circles here, cross them out, and I can cross out these 3 circles. And then I'm done because there's nothing that is in common on one side of the equation that's also in common on the other. So what I am left with, the answer to this question, if this was a test question, you would draw the shapes. You would have 1 square equals 2 circles. That's like the weight, since we're thinking scales, or we can think of value. So the 2 circles equals the 1 square, or you could say the 1 square equals 2 circles. Okay, your independent work, if you did not do that already in class, here is what I'm asking you to do. It's page 378, exercise 20C.1, and numbers 1 and 2. Numbers 1 and 2, well, number 1 has a lot of questions within it, so please answer all the questions within number 1 and number 2. And like always, questions and answers, please. And then in this case, the questions are actually pictures like this, okay? So I would like you to draw the scales, or at least at the minimum, draw the shapes that are in the scales. Like this first one has some V's and some O's. Draw an equal sign or the balance being between them, and start to see what is the relationship between the objects, okay? So my best advice to you with equations like this, cross out one thing. I'll even kind of get us started on this first one. I have a V on this left-hand side. I can cross that out. First, draw it all, please, so it's easier to see. And then I can cross out a V over here, okay? Now, there's an O on the left-hand side. I get rid of an O. On the right, there's another O. On the left-hand side, another O. Oops, daisy. Another O on the right. And it doesn't really matter which side I start with. I see 2 more O's here on the right. I'm going to get rid of those because I can get rid of 2 more O's here on the left. At this point, there's nothing that's the same on either side. So I am left with 1 O equals V, okay, 2 V's. So if you want to say V plus V, that's fine, or just draw the 2 V's. And that's your answer to that kind of question. So please do the rest on your own, B, C, D, E, F, G, H, I. And number 2 as well. It kind of got cut off on the screen, but It has to do with strawberries and bananas and the relationship between those using balanced equations.